Hi everyone, welcome to another episode of Coding with Chinese Man. Today we're going to look at the valid anagram problem, and this is a LeetCode Yeezy problem. However, it comes up fairly often, so therefore it's in your best interest to know this fairly down pat. So the question is, given two strings s and t, write a function to determine if t is an anagram of s. So first things first is, what's an anagram? So an anagram is essentially any two strings where they have the same characters. So essentially, by rearranging the characters in one string, you're able to make the second string. So it's an anagram if that is true. It is not an anagram if that is false. So for example, anagram and nagram are anagrams because you can rearrange anagram into nagram. However, rat and it cannot be rearranged into car because you don't have a C and you have an extra T. So I guess a couple of quick checks that you could do would be, are the strings the same? If they're not if the strings are the same length. If they're the same length, then it might be an anagram, it might not be, but you know that if it's not the same length, it cannot be an anagram because you'll have characters left over from the longer string. So I thought about several ways to do this. And for this problem, we use a sort and compare method. It's going to be, I believe, n log n. And another method we could do would be to count the number of characters and create a counter object that counts the number of characters. And the reason we might want to do that is because thinking about the counter object, so if we have the count of each character, and those counts match the other string's count, then therefore you have an anagram. So for example, if there's 15 T's, 7 Z's, 5 S, and 3 A's, and if that same count applies to the second array, the second string, then you know it's anagram. Why we would want to use those counts is if you have a very long string and you want to compare more than once. So for example, if you have, say, a 2,000 character string, you don't want to check 2,000 characters every time to every other string. You just want to check up to 26, or 52 if lowercase and uppercase are different. But in this case, we're only comparing two strings and only doing it once. So here we just kind of skip that and use a user to code method. So what do? We turn the strings into arrays. So that's what we're doing on lines 7 and 8. And the reason why we use arrays is because it's easier to sort arrays in JavaScript than, for example, to sort a string in JavaScript. So after you created the arrays, what split does is the input is just nothing. What that means is it'll separate every character into a separate element of the array. So in the case of anagram, for example, it'll become an array of 7 elements. First element A, second element N, third element A, fourth element G, and so on. And then we sort the arrays. If we don't specify a callback, it'll do a default sort, which sorts alphanumerically. It can have some weird behavior if you're sorting a number that's a string, for example. But in this case, it's fairly straightforward. It's just all letters, and it's only lowercase alphabets based on the note. So this sort will work. If it's a more complicated sort, you just want to be careful that you pass your own custom callback to the sort function, or you're very familiar with what the default behavior is. And then we compare the arrays. So essentially, if every element of the first array is equal to the second array same element, then great. But if at any point it's not, then it's false. And so what that means is, so for example, anagram and nagram, we could do some console logs here to kind of show you what the sorted array looks like. So after we convert the string to the array and we sort the arrays, anagram and nagram, anagram becomes A, A, G, M, and R, and anagram is AAGMNR. So essentially it just sorts it by the character. And even if there was some really weird behavior that is non-intuitive on the sort, as long as it applies equally, it should be the same, because we're looking for strings that have the same characters. So that way, when they're sorted, even if they're sorted reverse alphabetically or vowels first and then consonants or whatever, if it's an anagram, it'll still be sorted in the same order. So that's why the sort doesn't really matter too much here in terms of how we sort it, as long as it is sorted. So now that once it's sorted, we go through the arrays and we compare each element at the same index between the arrays. Because if it's an anagram, it has the same number of characters and it has the same characters, just in a different order. So as an example, if we use rat and car, or ratty and rat b, this will fail, and the reason for that is noticing the sort. So ratty, it's sorted to ARTTY, and then rat b, it's A, which matches, and then R and B don't match, so it just fails right there. So that's why the ordering is important, and we look to the same index of each. The reason ordering is important is because we want to ensure that the same number of characters exist for both strings. So that will compare up to the first length. If we do a max of the first and second array lengths, that won't work because some of it will be undefined. We could have a type of, for example, or a check to see whether it's defined or undefined in a short circuit, but that's extra code that makes this if statement a little bit more complicated to read. So that's why we only sort up to the first length, and if it's definite lengths, then it's also false. So what this does is, for example, if it's ratty and ratty with two y's, for example, this will fail, and the reason why it will fail is because there's an extra character at the end, so it'll go through ARTTY, and this array from this loop from line 15 to line 19 finishes, but it's not an anagram because there's an extra character in the second string. So that's why we have this extra check here to make sure that it's exhaustive. And what that means is if we check that all the lengths of up to length I for the first array is the same, and then we want to just make sure that that the second array gets fully checked as well. One thing we want to make sure is that we didn't check to make sure it's undefined here, but if S of I is undefined, it's not going to equal to something that is defined, so we don't have to worry that much about if the first array is longer, for example, because undefined does not equal to Y. So I take back what I said about the undefined throwing an error, because we're not accessing something of undefined, we're just accessing undefined. And there we have it. So this will check to see what's an anagram. And the recap is all we need to do is just change it to an array, sort the array, and then compare the characters in each array to make sure they're the same. And if at any point it fails, then we return false. And if after all our checks to see whether it fails doesn't get hit, then we return true because it's an anagram. So that's the overall strategy of how to solve this problem. I hope that helped. And this problem is fairly simple, but it does come up very often, so I do encourage you to become very familiar with this problem, as well as follow-ups to this problem, because there's a lot of different variations of anagram problems that you want to be familiar with. So if you like my video of breaking down not only how to solve algorithms, but also my thinking process as I go about solving it, feel free to hit that like and subscribe, and even share with your friends too, because sharing is caring. So quick thing on the Lagrange complexity, the time complexity here. So we do a split, O of n, sort, and log n, compare the arrays, O of n, and then the different length is O of 1. So therefore, the biggest big O notation that we have for time complexity is O of n log n. In terms of space, we're getting 2 extra arrays. that mimic the string, so that would be just an O of n space. Even though it's two arrays, we don't really say O of 2n, even though that's true. O of 2n just equals to O of n because we want to take the significance of it rather than the specific constant. So yeah, hope you enjoyed the video, and I'll see you on my next video. Welcome to another episode of Chinese Man Coding.